Welcome to Fresh Thinking School of Brain Science. How depression affects the brain. Depression, often misunderstood as a mere state of sadness, is a complex and debilitating mental health disorder with profound implications for the brain. Beyond the emotional turmoil it inflicts, depression leaves a tangible mark on the intricate workings of our most vital organs. Scientific research has revealed that depression is not simply a chemical imbalance, but a multifaceted condition that can alter the brain structure and function. These changes can manifest in various ways, impacting memory, decision making, emotional regulation, and overall cognitive function. From the hippocampus, responsible for learning and memory, to the prefrontal cortex, crucial for planning and problem solving, depression can disrupt the delicate balance within these regions. This masterclass into the depth of depression's impact on the brain aims to shed light on the underlying mechanisms that contribute to this pervasive disorder. By understanding the intricate interplay between depression and the brain, we can pave the way for more effective treatments and interventions, ultimately offering hope and healing to those affected by this often misunderstood condition. Depression is a complex mental health disorder that has a significant impact on the brain. Research has shown that depression can cause both structural and functional changes in the brain, affecting various regions and processes. Structural changes. Hippocampus. The hippocampus, a crucial brain region deep within the temporal lobe, plays a pivotal role in our ability to learn and form new memories. This intricate structure is a gateway for information processing and consolidating experiences into lasting recollections. However, the insidious grip of depression can cast a shadow over this vital area, leading to a reduction in its size. This shrinkage of the hippocampus has profound implications for cognitive function. As this region diminishes, so too does our capacity for memory, learning, and spatial navigation. The intricate neural connections that once facilitated the creation and retrieval of memories become compromised, resulting in difficulties concentrating, retaining information, and recalling past events. The impact of depression on the hippocampus underscores the interconnectedness of our mental and physical well-being. It serves as a stark reminder that emotional distress can leave a tangible mark on the brain, affecting not only our mood but our cognitive faculties. Understanding this intricate relationship is crucial in developing comprehensive approaches to treatment that address both the emotional and cognitive aspects of depression. Prefrontal cortex. The prefrontal cortex often called the brain's executive center, is pivotal in making decisions, planning for the future, and solving complex problems. This intricate network of neurons at the front of the brain acts as a conductor, orchestrating our thoughts, actions, and emotions. However, depression can disrupt this harmonious symphony. Research indicates that depression can dampen activity within the prefrontal cortex, leading to a range of cognitive difficulties. As this region becomes less engaged, our ability to concentrate, weigh options, and make sound decisions may falter. Tasks that once seemed manageable may now feel overwhelming, and the simple act of focusing on a single thought can become a challenge. This diminished activity in the prefrontal cortex not only affects our cognitive abilities but also contribute to the emotional and behavioral symptoms of depression. The intricate link between this brain region and our mental well-being highlights the importance of holistic approaches to treatment that address both the biological and psychological aspects of this complex disorder. By understanding how depression affects the prefrontal cortex, we can develop more targeted interventions that aim to restore its function and improve overall quality of life for those affected. Amygdala. The amygdala, a small almond-shaped structure nestled deep within the brain, serves as a central hub for processing emotions, particularly those related to fear and anxiety. This intricate region acts as a vigilant sentinel, constantly scanning our environment for potential threats and triggering our body's fight or flight response. However, in individuals grappling with depression, the amygdala can become hyperactive, akin to an alarm system stuck in overdrive. This heightened arousal can lead to a cascade of emotional and physiological reactions. Everyday events may be perceived as more threatening. Minor setbacks may trigger overwhelming anxiety, and the ability to regulate emotions may become compromised. This overacting amygdala not only intensifies the emotional burden of depression, but also contributes to a vicious cycle. Increased anxiety can exacerbate depressive symptoms, leading to further emotional dysregulation and a heightened sense of vulnerability. Understanding this intricate interplay between the amygdala and depression is crucial for developing targeted interventions that address both the emotional and psychological components of this complex disorder. By restoring balance to this vital brain region, we can help individuals regain control over their emotions and navigate the challenges of depression with greater resilience. Nucleus accumbens. The nucleus accumbens, a key area in the brain's reward system, plays a crucial role in motivation and pleasure experience. When this region functions optimally, it drives us to seek rewarding experiences and reinforces positive behaviors. However, individuals with depression, activity in the nucleus accumbens can be diminished. This reduced activity is thought to contribute to anhedonia, a hallmark symptom of depression characterized by a loss of interest or pleasure in one's enjoyable activities. The lack of motivation and inability to experience pleasure can create a cycle of withdrawal and further exacerbate depressive symptoms. Understanding the connection between the nucleus accumbens and anhedonia may lead to new treatment approaches that target this brain region to alleviate this debilitating aspect of depression. Functional changes. Neurotransmitter imbalance. Depression, a complex mental health disorder, often intertwines with the delicate balance of neurotransmitters in the brain. These chemical messengers, including serotonin, dopamine, and norepinephrine, regulate our mood, emotions, and overall well-being. When these neurotransmitters become imbalanced, the harmonious symphony of brain activity can falter, leading to their emotional and cognitive disruptions characteristic of depression. Serotonin, often dubbed the feel-good chemical, influences mood, sleep, and appetite. A decrease in serotonin levels can contribute to feelings of sadness, anxiety, and irritability. Dopamine associated with reward and motivation may also dwindle in depression, leading to a loss of pleasure and interest in activities once enjoyed. Norepinephrine, involved in alertness and energy, can become depleted, resulting in fatigue and difficulty concentrating. While the exact nature of these imbalances is still under investigation, research suggests that a deficiency does not solely cause depression in a single neurotransmitter. Instead, it likely involves a complex interplay of multiple neurotransmitters, their receptors, and the intricate pathways they traverse within the brain. Neurotransmitters in the brain, stress response. Depression, like a storm brewing within, can disrupt the body's delicate stress response system. This intricate network, designed to protect us from danger, can become dysregulated in the face of chronic emotional distress. As the storm rages, the body releases a surge of cortisol, a stress hormone that prepares us to fight or flee. However, when cortisol levels remain persistently elevated, as is often the depression case, it can wreak havoc on the brain. This potent hormone, meant for short-term bursts, can become toxic when chronically elevated. It can impair the hippocampus, a crucial brain region responsible for memory and learning, leading to difficulties concentrating and recalling information. Moreover, high cortisol levels can disrupt the delicate balance of neurotransmitters, those chemical messengers that regulate mood and emotions. This can further exacerbate depressive symptoms, creating a vicious cycle of stress, hormonal dysregulation, and emotional distress. The detrimental effects of chronic stress and elevated cortisol extend beyond the brain, impacting various bodily systems and increasing the risk of developing other health problems such as cardiovascular disease, obesity, and weakened immune function. Neural pathways. Imagine the brain as a vast network of interconnected highways, with neural pathways serving as the routes for information to travel. Depression, however, can act like a disruptive force, throwing roadblocks and detours onto these vital pathways. This disruption in communication between different brain regions can have far-reaching consequences. The prefrontal cortex, responsible for decision-making and planning, may struggle to connect with the amygdala, which processes information and emotions. This can lead to difficulty regulating mood and responding appropriately to situations. The hippocampus, crucial for memory formation, may become isolated, contributing to forgetfulness and difficulty concentrating. The brain's ability to function harmoniously is compromised as these neural connections falter. Cognitive functions like attention, memory, and problem solving may decline. Emotional regulation becomes a challenge with heightened sensitivity to negative emotions and difficulty experiencing pleasure. The intricate web of neural pathways is essential for maintaining a healthy balance within the brain. When depression disrupts these connections, it can lead to a cascade of effects that impact both cognitive and emotional well-being. Understanding this intricate relationship is crucial for developing targeted interventions that restore these pathways and promote optimal brain function, treatment, and recovery. Though depression's grip on the brain is undeniable, it is crucial to recognize that this formidable foe can be overcome. While neural changes induced by depression may seem daunting, they are not immutable. The brain possesses an astonishing capacity for adaptation and healing, known as neuroplasticity. With appropriate intervention, the brain can begin to mend the pathways disrupted by depression. Antidepressant medications, for instance, can help to restore the delicate balance of neurotransmitters, those chemical messengers that regulate mood and emotions. Psychotherapy, on the other hand, can equip individuals with coping mechanisms and strategies to reframe negative thought patterns, promoting emotional resilience. Furthermore, emerging research suggests that lifestyle changes, such as exercise, mindfulness, meditation, and a healthy diet, can also promote neuroplasticity and facilitate recovery. These interventions, when combined with professional guidance, can create a powerful synergy that empowers the brain to heal and adapt, ultimately reversing some of the damage inflicted by depression. The road to recovery may be challenging, but it is not insurmountable. By embracing a multifaceted approach to treatment, individuals can harness the brain's remarkable capacity for change and reclaim their mental well-being. The intricate relationship between depression and the brain paints a complex picture, one where emotional turmoil intertwines with tangible physiological changes. From the depths of the hippocampus to the vast expanse of the prefrontal cortex, depression's impact reverberates throughout this vital organ. Whereas the findings presented here may seem daunting, it is essential to remember that the brain is remarkably resilient. Many of these changes can be reversed or mitigated with appropriate interventions and treatments, such as medication and therapy. Neuroplasticity, the brain's innate ability to reorganize and adapt, offers hope for recovery and healing. As research into the neurobiology of depression continues to advance, so too does our understanding of this intricate disorder. By unraveling the complexities of depression's impact on the brain, we move closer to developing more targeted, effective treatments. This knowledge empowers individuals, families, and healthcare providers to approach depression with a comprehensive understanding, fostering a path towards recovery and improved well-being. In the face of depressive's profound influence on the brain, there is hope. By embracing scientific inquiry and compassionate care, we can navigate the intricacies and the intricate landscape of this disorder and pave the way for a brighter future for those affected by its grasp. This is Dr. Masasikani Misha, Kosa, Director of Fresh Thinking, School of Brain Science. Make sure you subscribe to the YouTube video because you will be amazed. We offer the very best information ever. Thank you very much. Thank you.